So Dan's going to do a quick update on,
on 2 minutes.
4 new things from Ignite.
Okay, cool. Thanks, Dave. Thank you, everyone. Hey, real quick, 2 minutes. Anyone here go to Ignite? Other people, anyone here know Ignite was on? Okay, we did an all right job. We let you know you didn't make it. That's okay. So I'm going to give you 4 things that I thought were interesting about Ignite that you should possibly be aware of. So the first one is Azure Savings Plans. So anyone here familiar with reserved instances? Yep, lots of people reserved instances. Azure Savings Plans essentially allows you to commit to a baseline spend across a bunch of different compute, but it doesn't matter the type of compute. So it's kind of like general purpose RIs, no location restriction. You know, you don't have to say, I want, West US or whatever. So that was key. I think it is worth looking at. Azure AD workload identity, any Kubernetes, any AKS people? Yeah, well, you don't count. Ahmed, you count. That was a really important one. Anyone is using AKS, workload identity allows your pods, and we actually got engineer from the AKS team. So, but yeah, the workload identity allows your pods to communicate with Azure in a secure fashion, getting an identity in Azure AD, which is really important. So this supersedes something called Azure AD Pod Identity V2 that was in preview for like months or years. Third thing, Azure Premium SSD V2 disks. So this is quite an interesting thing. Basically gives you flexible IOPS and throughput on premium disks, allowing you to get much higher performance out of an individual disk and basically dial up this performance up and down. That's in preview. So if you've got VMs that are being bottlenecked by IOPS and you don't want to go to Ultra Disk, that's a good option. And the fourth thing, GitHub Advanced Security for Azure DevOps. So advanced security is a feature of GitHub, which did things like secret scanning in your repos, package scanning and dependency scanning, and code scanning for security vulnerabilities. That was only available on GitHub. And we told you, no, go to GitHub if you want these things. Now we're telling you, no, you can get them in Azure DevOps. So if you are running Azure DevOps, which probably a lot of people are, get this. It is well worth the price of admission. It is just probably one of the key things you're going to do to get a better.
Is this the same as the Azure Defender for Cloud for DevOps? Or
I don't know if it is. I think they're actually different things. We like to keep you guessing. Yeah, it's interesting, right? No, I think this is it. Well, I don't think it is. I'm gonna have to check. Good question. Anyone online know, or anyone in the room know?
They're not the same thing.
There we go. So there we go. So that is 4 things. Oh, there was one more thing I need to talk about. We also have 2 more meetups before the end of the year. So recommend going to, so we've got Judy Marcello, she's the head of Architecture Countdown, talking about their architecture journey. And we've also got Galina Poliakova, who's one of our senior CSAs here, going to be talking about Cosmos DB and modeling, which is super important if you're using Cosmos DB. I cannot recommend this enough. If you are using Cosmos DB, yeah, or if you're thinking about it, be there. So anyway, that's me done. It was long the 2 minutes.
ADO, is that Azure DevOps service or server or both?
I think it's only services. Oh, it might be server. I just don't look at server anymore. So to be honest, services, yes. Server, maybe. But if you're using anyone using server? Anyone online using Azure DevOps server? No. So there we go. Oh, don't. Well, not back to you, Dave.
Work at a bank, we have to. All right, so next up is Chimes. So Chimes is a CSA here at Microsoft, although she doesn't like the term CSA, so just refer to her as a jack of all trades, but really just super grateful to have her here to talk about unified edge computing. Not something that I personally get a lot of exposure to, so really looking forward to the session. So yeah, thank you so much, Chimes.
Hello everyone, and to my Aussie colleagues overseas, how bloody hell are you? Because yes, I'm Australian, hence this dodgy accent. So good luck to this transcription service trying to debug what I'm saying. So part of unified edge computing, it's a new coined term that we're going to go through today. It encompasses a number of different services, not just on Azure, but other cloud providers as well. So with today's session, we're not going to go too deep into the code base and how to hook up different parts of edge compute to the cloud. Rather, it's more of a level 100, 200 discussion that I'd like to have with you guys if you would like to contribute as well, some of your experiences in edge computing. And the reason why I say that, because I know we've got a few heavyweights in the room. Yeah, I'm looking at you. And on the call as well, who I've been working with in Australia. So part of my background, I've been at Microsoft for about 5 years now, predominantly as the tech specialist, CSA, whatever term they decide to give me, doing data and AI, IoT, edge, digital twins. So part of what I'd like to do today is that's my QR code if you would like to harass me on LinkedIn as well. I'd like to firstly cover, just so we can touch base, what is unified edge? So it's a term that we've only just coined recently, probably more of a Microsoft term, I would say. And it's an extension on the traditional edge concept, using a set of different technologies, whether it's Microsoft technologies, GCP or AWS, or even third-party or on-premise technologies that different customers would find useful in terms of operations, IT, data science, to solve real-world problems that cannot be addressed separately on-premise and or in the cloud. So the first definition we have is OT Edge, operational technologies. And that's looking at data nodes such as sensors, devices and modules that connect and transmit data that are close to where the business operations are performed. We most often see this in manufacturing and utilities and telcos on-prem as well. IT Edge. OT and IT Edge I found with customers, they don't often have very good communication, but the IT Edge, they focus predominantly on per store server infrastructure and networking as well. So often when I talk to customers that are trying to get them to build a hybrid infrastructure for IoT, getting these two teams to talk to each other is always an initial challenge, to getting to open ports so that we can connect different services and APIs in order to transmit data between on-prem and cloud. The next form is hybrid. So this is a deployment capability and operation methodology. So this is the one where we use infrastructure and application data services to be deployed consistently on public, cloud and IT Edge. And lastly, we have IoT, Internet of Things. So this is a collection of managed platform services across Edge and cloud, using services to connect, monitor and control billions of IoT assets. I say billions quite lightly because we're not going to see that in New Zealand or Australia. It's more so in the tens of thousands, hundreds of thousands when it comes to ANZ at least. So what I've done is put together a slide called the Unified Edge Spectrum. Now this looks like Microsoft, but it can be applied to also AWS and GCP services as well. So when we look at the plane, we see that first and foremost, the devices are going to go through OT Edge, through the SCADA systems, then through IT, and then furthermore into public cloud. It's then from there where you can deploy services such as Azure Arc or Azure Stack to further manage and control those planes of services. But something that a lot of people often don't talk about is the plane between the edge and the public cloud, and that's the fog compute piece. So when we compare different computes when looking at the edge, there are different places where you might want to process your data. One can be you can process it on the edge, you can process it on fog. Well, fog determines where you want to process it, or you can process it on the cloud. It depends on where you want your data to sit and how much data you're able to process over that network connection. A lot of it has to do with privacy, but also data governance as well. So with edge, latency is quite low when you want to do the compute on the edge. That's because the device or the service would be quite heavy in hardware to be able to do that compute. It might have some GPUs or CPUs that can actually do that level of processing that would normally be able to do in the cloud. So, and we'll go through the costings. We'll do a bit of an experiment on the costings of what this looks like, because Azure IoT Edge costs nothing. But when you look at that cost actually has to go somewhere, and often it's the hardware, and that comes back to the customer, the business or the third-party provider who would look after that piece. It's from there where you would look at the fog compute layer, where the fog compute layer would decide, would I want to process this data on the edge or would I want to process it on the cloud? And this is quite good if you're dealing with any data that's PII sensitive, in terms of facial recognitions, which is what we see a lot in retail in the supermarkets, or alternatively, maybe you don't want large amounts of data being processed to the cloud, because that can also come at quite a high cost as well, and further increased latency. So often when we see edge computing, we mostly see it being used, as I said earlier, in manufacturing, utilities, and retail. And some of the use cases that we also see in terms of top edge computing workloads is mostly in AI. And I'm happy to hear anyone who might find that their experiences are different in that space as well. Anyone online? Have you experienced, or are you deploying something different than what we're seeing here? So tempted to call on you, Harvey, but I won't. I know you're a shy bloke. Okay, so. Oh.
Some of those.
Huh? All right.
I was gonna say, like, it probably falls under other, but like I end up having to deploy things onto like air-gapped on-prem services that like we have to go through with a USB drive to actually like get the data off of it for further analysis, because it's sensitive, or the facility could, you know, start on fire if it would be infected through something. So like some of these are just because of a separation from the actual cloud itself that we don't have the ability to transport with. Yeah, it falls under the other, but it's like the most common use case for me.
That's pretty sad.
In the slide before that, you talked about the edge, and you said one of the reasons would be a decision making. So you need a computing device in the edge to, sorry, before that. The slide before that. Yeah, so the reason, like real-time instant or decision making. So what would be like an example of where would you want an edge to make a decision?
Depending on in one case, it would be dependent on the file size. That's most often where I see the fog compute making that decision. No, Tom, think something different? It's going on you randomly, mate.
Well, for us, like if there's control on site that you don't want to pass up to the cloud for processing, that's where high latency would be important, but low latency, obviously. That's the one I could think of. Privacy is important, but it's a different topic. Yeah, really local control, quick feedback where you don't want to pass it up to the cloud before coming down.
With driving a car to a gas station and then recognizing your plate, you would be able to pay without going without going inside to pay. Would that also count as an edge? For example, you got a car, recognize the plate, you've already registered your name before, and you would be able to pay without going in. Would that also be an IoT edge?
I think it would depend on the service provider and with the installed station. But at the moment, it's edge compute, yes.
I mean, one more, I guess, is where you don't necessarily always have connection to the cloud.
Yes, exactly. Offline capability in case there's.
Awesome.
So,
Thank you.
yeah, I mean, edge computing for us is about making sure we don't have system failure. So that's an individual system. But then in terms of overall optimization, it's multiple sensors, which is edge, coordinate, we have to bring it up to the cloud.
Yeah, thank you.
Input. Thanks, Jim. I told you it would be a discussion, not just by PowerPoint. So what I've also done, and this is Gartner because I love third party, not just making you drink the Microsoft Kool-Aid, some edge computing challenges that we sometimes see. One of them, and I did talk about IT and OT challenges. Sometimes the data between those two teams can be disparate, and they don't merge. So that's also one challenge that we have. Patchwork's approach to security, cumbersome cloud to edge management, lack of application extensibility, but also conflicting choices in which providers, services, and devices to use as well, and how the security layer works on top of that. I find that it takes a couple of months usually, if all parties are talking to each other to reach a consensus before a project can get started in this space. But once that's done, it only takes probably, I think, about a year from what I've seen at least, or experience. Anyone can challenge me differently, to have that discussion between the teams and actually get something feasible like a pilot up and running for unified edge computing. Has it taken anyone else any longer, or have you experienced any other challenges apart from USB man? Haven't really got to that stage yet.
It's different problems, right? Like some of the issues that we have around are usually around like privacy, as you've mentioned, around how can this data be abused and what kind of interfaces are required. And yeah, again, a year is pretty spot on in my experience. How long that takes.
If you did it in less, I'd be like, I have to learn from you now.
One thing with Chimène is at the moment, obviously with COVID and supply chain issues, availability of hardware is a big issue, which is not necessarily a technology issue, but it does play a part. So you try and work around it with but you have to find different ways.
Absolutely. That you actually really raised a really good point, because hardware is really hard to come by at the moment. I know trying to order a whole heap of devices from Taiwan, and it takes more than 8 weeks, let's say, and it's a heck of a process to get that PO out, and trying to do a proof of value or a pilot while you're waiting on devices. So you've got to do a lot of activities in parallel for you to get something out in a timely manner. Current challenges in post-COVID, or in the middle of COVID. So another thing that I'd like to do, and I realize that we're in the church of Microsoft, so to speak, but I'd like to talk about GCP and AWS. I like stirring the pot. So there are other services other than Azure, yeah. And more often than not, and the reason why I'm bringing this up is because when I talk to different businesses, they're not always going to be greenfield, they're brownfield. They already have existing assets, whether it's devices, partnerships, or existing services that they want to add more capability on top of that use case that they probably can't get with their existing installed services. So more often than not, I'm actually working more with AWS customers now than GCP. And I'm not sure if GCP customers saw this coming, but they had actually an end of life announcement the last couple of weeks for IoT Core, which was quite surprising, because I actually thought, take your Microsoft hat, that was actually a pretty good service, very capable service. I don't know if anyone else has been impacted by this announcement.
I don't trust Google.
You don't trust people?
Not delete good things. Like.
Yeah. So I'm quite curious to find out how they're going to make it work. But as far as what I've heard, they're asking them to existing customers to migrate off to third party or other cloud providers. And I was like, it's big. And I think they're just trying to, what I heard is that they were trying to mitigate losses. To make the bottom line look better, and that the market was already saturated with other IoT services as well. So it's quite a shocking announcement, but something that I thought interesting that I'd share as well. So a lot of the, going back to the original topic, a lot of the methodologies that I have shown earlier in this session, you can actually do with AWS services, no longer GCP, maybe partially. but it's not uncommon when trying to implement unified edge computing that you're also doing multi-cloud, but also probably working with IBM services as well. On-premise, SCADA services as an example, or even third-party integrators such as Titled IoT Bridge, Ketware Server, or Friendly IoT for protocol translation. It's unified edge it's not an easy one, I have to admit, because you're dealing with a lot of different components. And that's where it takes me to this very high-level decision tree of when you would go with one or the other from an Azure perspective. I mean, I'm sure there's one existing for the other server, for the other cloud providers as well, but this is generally our guidance on when you would use which service over the other. Definitely for multi-cloud, and I've seen this, and I can see some of the customers I work with are online. They know we've already deployed this way. With multi-cloud, we've had to use either containers, VMs, or SQL in order to make multi-cloud a possibility for them, in particular in regards to their project. I won't talk too much on that because it's that's proprietary to them. But some key considerations that we would have in this space, and it's a real pain point. It takes a long time to go through all of every customer's IP, make sure all the teams are aligned in the organizations before deploying unified edge. And that's to make sure the ease of use of hybrid and edge computing. Most of the time when I talk, not to the decision makers, but to the teams themselves who have to deploy, they're mostly like, oh, another bloody UI. What button do I need to press to make this work? Is usually the response I get. And the availability of third-party applications or solutions. So, and one of this could be the ability to do protocol translation. In particular with SCADA systems, a lot of the customers I deal with at the moment are struggling with some, I would say, archaic protocols that they cannot move away from because they cannot yet retire that SCADA system or upgrade it to a new one. I had one with a protocol translation for DNP3. That was fun to try and link to Azure services because we don't support that natively, and we don't have a third-party provider that also supports it for bi-directional communication. So you can imagine that was a truckload of fun trying to solve. I won't tell you how we solved it. Maybe that can be an offline conversation if that's something that you're also struggling with. So integration is also a big piece as well. If you want to go bi-directional, or if you want to lock down, do a private link on those APIs, it starts getting quite complex. Reliability of the hybrid cloud and edge computing, so SLAs. So if you're buying into hardware, what's the cost of ownership? Who's looking after it? Is it the hardware provider when you're looking at updating firmware over the air? Or are you doing the computing in the cloud? In that case, the SLAs would be on the cloud provider. So if there's a point of failure, who's going to look into it? I did have a case, a severity 4 ticket a few months ago, which kept me up for a couple of weeks, where the handshake was not working between device to cloud. And obviously the point first came to Microsoft because, but we found out that it wasn't actually Microsoft, but it's having the reliability and finding those point of failures in the pipeline. So there were a couple of reasons why in this case it was quite interesting. The TCP handshake was not working in certain Azure regions, but it did work on overseas regions. And it could also be because maybe the network provider, let's say Telstra, Vodafone, or Optus, or Spark, were not doing the TCP handshake properly. There are whole different areas where it could fail, but it's about who's at fault and how do you go to find the root cause analysis when these things don't work. But the more services that you bring in there, the more fingers to point. So that was a bit of fun that I had on a Sev4 ticket earlier this year. It's something to take into consideration.
I just ask one question. Why aren't they doing a ping test? Simple.
Oh, it was more complex than that.
I know it was, but that tells you something. The 7-layer stack, it still tells you something.
So I can't tell you why it
Doesn't matter.
happened, but
Doesn't matter.
I can assure you the ping, they did do it.
They did do that. I just wanted to make sure. I'm just being cheeky. You know what I'm talking about.
Sorry, which region was it? Which region was it? But the telco had the issue.
It was to do, all right, there were a number of things that were wrong here. It had to do with certain pieces of hardware in the device itself. And it also had to do with the network provider. It wasn't Microsoft, let's put it that way.
Understand.
I had product group on it. It got to the point where even I was like, oh no, I don't freaking know anymore. But yeah, it had to do with the device and the network provider that were not in sync. And what they did was they transferred, they going to migrate onto different devices that can actually talk to the service properly.
You had a resilience problem. You had a resilience problem, didn't you? That's the work at under control. We don't have a resilience problem in the network. People's lives count on it. The radar data is pretty important. I've said enough. No, we don't use Cisco gear, by the way. It's aviation grade.
The other one is the ability to deploy and manage edge computing workloads. So it's skilling up the team as well to be able to become familiar with those concepts and being able to take responsibility to a degree of certain parts of that deployment pipeline. And something that we're seeing a bit more of is automation and AI-led operations on the edge as well, which is some new capability that came out. I'm not sure if anyone saw at Ignite that you can have cognitive vision on the IoT edge now, which is quite exciting since Percept has announced retirement. So some things are updating. Unfortunately, we have lost Percept in that sense. So I'm a GIF and a meme person, so I hope you like this. So next is activity and discussion. I want to do a service cost comparison and investigation. I'm going to look at the Azure one because I don't even want to talk. I know AWS and GCP will come for me if I start talking about their services because they probably want to pitch in. I'm just going to see how I can share this without being. See if this works. All right. We're almost done, folks. Just another 5 minutes. So what I've done is I've taken a couple, I'm on my Azure pricing calculator. Can you want to see that? No. So duplicate. I have no secrets. So what I've done is I'm on the Azure pricing calculator and I've taken a couple of our IoT unified edge services just to do a bit of a cost compare, because as you know, when you're looking at where do you want to do the compute, cost of ownership and responsibility comes into play. So Azure Stack Edge, for those who don't know, these are our devices where IoT Edge is deployed in the device itself, and you can Microsoft hardware running on site for you that has native plug and play integration to IoT Hub and IoT Central. This is the more expensive piece, but you'd be looking at something similar if you were to go with another hardware provider that was Azure device certified, let's say. If they weren't Azure device certified, then you would have to install the device C SDK onto that device itself, depending if the device has enough enough memory to hold the device SDK, which is a lot of the problems that we see now with some of the light devices in the space. What's this la-di-da?
Well, if you go to the right thing in the first place versus it's like installing Windows on top of Windows on top of Windows. I mean,
Yeah. Well, sometimes a light device is actually more appropriate in
That's what I'm
some
saying.
cases, yeah, than having a full, then it's like hitting it with a sledgehammer if you go Azure Stack Edge, let's put it that way. And sometimes all you just need is
So
a
it'd be
temperature reading.
heavy if you've got a party on top of a food party.
You just need a lightweight, easygoing sensor. Like our Stack Edge ones could probably survive a hurricane, but that's, they're very hardy. And what I was mentioning earlier is that there is the Azure IoT Edge. What this gives you is the capability to make a gateway to connect to the Azure cloud. As you can see, it costs nothing, but that would depend. But that's because the cost is being passed on to the customer and the device that they choose, and if they're going to compute on the edge or the cloud. And if you wanted to, with the Edge runtime, actually install Edge modules on it. So currently we've got customized vision, which I previously mentioned, that just got announced at Ignite. You can do stream analytics on the Edge, Azure Functions, or bring your own license to have an Azure SQL database as well.
Cool.
So that's where that would differ. And IoT Hub and IoT Central, these are our bi-directional communication services just for receiving the messages. And that would also depend on how many messages you would receive a day and how many devices as well. So here with our tier S1, 400,000 messages. This is all in Aussie dollars, by the way, all in Australia East. And IoT Central, which is more your plug and play PaaS service, APaaS service. So cost does, if you're looking at just cost, a lot of folks will go, oh, sweet, IoT Edge, just put that in, but then the cost comes back to yourselves. It's really trying to find out where is most appropriate to do the compute, data sovereignty, PII, and what the business requirements are. Or even if they're open to having the conversation, where's the most logical place to do the compute? So there are a couple of things to go through before actually choosing if you wanted to do the compute on the cloud or do it on the edge itself. It was it. So any questions or just go, oh yeah, Tom, go, my man.
We used to have one of these, but one of the things we ran into was redundancy on the edge. So you really need more than one.
Yes, you do.
Redundancy on one device. Is anything built in for that, or sort of how do you have to manage that yourself? So you basically buy 2 stack edges and then manage your own redundancy, or what's the setup?
Normally you would have 2 as a backup. What I can do is I can send you the GitHub repo on how to manage that.
Because I mean, the cost obviously doubles because the stack edge is the most expensive component.
I don't see too many people using Stack Edge, to be honest. You had money to spend.
Oh,
having fun.
It became quite cost prohibitive because of the redundancy for us. I mean, it's a very nice piece of hardware, but heavy duty, you still need a server rack on the edge because it's a massive. I mean, you had a smaller one in the edge.
Which one did you get? Did you get the rugged or?
No, not the right. We were early access, so.
Oh, well, that's probably why redundancy was early access. You were the guinea pig.
The one with they had a GPU. It was the one with the GPU, so it was the big monster.
Yeah, you were the guinea pig.
Yes.
Anyway, it's probably changed since. It's most likely changed since then. When did you try that?
It's probably 1.5 years ago now.
Oh yeah, it's changed.
It wasn't available in the regions. We had to open up a Southeast Asia sort of region to be able to order it. Bit of a challenge, but no, we got one. A lot of noise, a lot of. The hardest part for us, because it wasn't a rugged, was still basically you needed a server room to put it in.
Oh, okay.
It ruled it out for a lot of edge cases, really.
If you had to put it in a server room, yes, it wasn't really rugged. It's more like its own little data center. Interesting. We can talk about this a bit later. You can show me a picture. See, like that. Learned something new today. Anyone else have any questions, or shall we finish up and eat cold pizza? Brilliant. Well, thanks everyone for coming. We've got more meetups coming over the next couple of months, so keen to see you all in the future. Thanks all.
Sit there. What next?